Welcome to the 2018 Hydrant Inspection Training Program. This year we're going to be doing things a little bit differently. This screencast will cover everything you need to know to get things done quickly and effectively. The Stanford Fire Department has been working hard with Cindy Barber of the Stanford GIS Department and the Aquarion Water Company to improve communications and data exchange between all three organizations. The hydrant data has been neglected for decades, and it will take some time to clean up. But once it's complete, we will have a really useful set of data to include in dispatch information, on the EAM screens, and in future pre-plan applications. We will be able to quickly identify hydrants from different water zones, allowing us to draw from two completely different water sources during major fires. The goals and objectives are to 1. Inspect each and every hydrant for a list of common issues. 2. Gather and record detailed data for every hydrant. 3. Pressure test and record the static pressure results for every hydrant in the city. This will help us determine which hydrants are on which zones, as well as help us to determine if there are any low pressure areas in the zones. 4. Pump the hydrants as necessary. I know this is contrary to everything we have ever been taught, but please do not flush any hydrants. We have been requested by Aquarion to not flush the hydrants this year due to issues in some parts of the water grid. They are concerned that the sudden flow and shutdown of water could cause a water main break. They are diligently working on the system and hope to have the entire grid stabilized soon. They have replaced over 50 hydrants this year alone, often putting them on larger mains while doing so. They will let us know when we can return to routinely flushing our hydrants. This year, we will be collecting data using the FireWeb. All of the mobile data terminals have been set up with Firefox. Please, don't use the mobile data terminal version of Internet Explorer. The MDT version of IE is extremely outdated and may cause problems with the app. You can launch Firefox and the Fire Hydrant Inspection app two ways. One is by using the FireWeb button on the MDT app. The other is to click the Firefox icon on the desktop. I suggest that you use the icon on the desktop, as some mobile data terminals are currently set up to launch Internet Explorer instead of Firefox when the button is pressed. We are working hard to get them all to launch Firefox when the mobile data terminal button is pressed, but that's going to take some time. Once you have the FireWeb open, be sure to log in. All data entered is timestamped with the user's information. Once you are logged in, click on the Mechanical menu and then scroll down to Hydrant Inspections. On the page that loads, you will initially see a list of all hydrants citywide. You can now narrow that list of hydrants by station, group assigned, as well as choosing to display only hydrants that need either the initial inspection or either one of the two follow-ups. The initial inspection form appears to be lengthy, but in reality should only take you a minute once you are familiar with the inspection report. So now, let's take a look at the data we're asking you to collect. Let's start with basic hydrant identification information. This includes the make, model, and year manufactured. You may not be able to find all this information on all hydrants, but do the best you can. There are only really 3 different types of hydrants we use in the city of Stanford. The first model we want to cover is probably the most common one you will encounter. It's called the Kennedy K11. It's easily identified by a screw-type collar connecting the hydrant to the riser. It'll have a smooth bonnet. Note that this hydrant provides extensive details on the make, model, and year it was manufactured. The next is the newer Kennedy K81A. It's easily identified by the breakaway bolts found connecting the hydrant to the riser. It'll have a smooth cap just like the K11. The only real difference between the K11 and the 81A is the type of coupling found at the base of the hydrant. The rest of the hydrant from the ground up is pretty much identical. The last type of hydrant you're going to encounter is the Mathews model by R.D.Wood. It's easily identified by a ribbed bonnet. These are some of the oldest fire hydrants in the city, and unfortunately, there's no useful information stamped on the hydrant, so we will only be recording the make and model of this type of hydrant. In the hydrant inspection form, enter as much data as you can. The condition found will be defined after we perform a pressure test, which we will cover later in this tutorial. If the hydrant fails to drain all the way after this pressure test, we will then be marking the hydrant as wet. Next, enter the make and model of the hydrant based on the information previously provided. Under the steamer type connection, you will be choosing either a threaded connection or a Storz connection. And finally, if you can determine the year of the hydrant, enter it here as a 4-digit number. So, what else are we looking for? Well, we've defined a list of attributes that will help us move forward in compiling a detailed database on one of the most important resources we depend on as a fire department. Once this data is collected, we can determine a list of priorities for improving the overall water delivery system for the fire service. The first thing we need to do is determine whether the GPS coordinates we have in our existing database are accurate. So, at the bottom of the inspection report are the GPS coordinates placed on a Google map. Zoom in and out as necessary and check the location to make sure it's accurate. If the pin does not match the current location, click the appropriate checkbox on the inspection form. Now we want to take a look at the hydrant gate valve and see if it's still visible. In the hydrant info section found at the bottom of the inspection report, you will find data pertaining to the location of the gate valve. The location is specified as feet in front of hydrant. Now that you know where the gate valve should be, take a look and see if you can find the cap in the middle of the street. Many gate valves have been paved over throughout the years. If you cannot find the hydrant valve cap, click on the appropriate checkbox in the inspection form. In the city of Stamford, every hydrant is supposed to have a flag already attached to it. If you see a flag, place a check mark in the appropriate box. If the hydrant you are inspecting does not have a flag and you try to install one, but are unable to do it for one reason or another, simply click the appropriate checkbox on the hydrant inspection form. There are some hydrants north of the parkway that won't meet any of the specifications we've talked about so far. Some have New Canaan threads, which prevent us from directly connecting to the hydrants. In order to fix this, these hydrants were retrofitted with a threaded adapter. If the hydrant has a threaded adapter present, click on the appropriate checkbox. In the past, some hydrants that were damaged were fixed using something called an insert. Basically, the top part of the hydrant is removed, leaving just the 5-inch stem cut at ground level. Then a smaller stem is placed inside the existing stem and connected to the existing valve several feet underground. Then the new hydrant is attached to the smaller stem. As you might guess, this results in less water than you might normally get. If there's any indication that an insert may have been used on the hydrant being inspected, be sure to click the appropriate checkbox on the inspection form. It's the policy of the current administration not to use inserts on any damaged hydrants in the future. Next, we want to inspect the base ring to see if it is or ever was painted red. A long time ago, a small group of hydrants located in high groundwater areas were purposely plugged, preventing backflow into the hydrant. These rings were painted red to indicate that the hydrant must be pumped after each and every use because they do not drain by themselves. Unfortunately, several years ago, the red rings were all painted over. Since then, some hydrant base rings have been repainted red, but many were marked incorrectly. This year, we will attempt to positively identify plugged hydrants during our pressure test. But in the meantime, if the hydrant you are inspecting contains a red ring at its base, click the appropriate checkbox on the hydrant inspection form. Some hydrants appear to be disappearing. Sometimes it's due to excessive landscaping, and sometimes it's for other reasons. If a hydrant is found to be too low to the ground, where opening the steamer cap will be difficult, click the appropriate checkbox on the hydrant inspection form. If you come across a hydrant that is hard to see from the road, click the appropriate checkbox in the hydrant inspection form. In the illustration shown, you can see a hydrant is well hidden due to landscaping. All Stanford hydrants should be painted yellow. If a hydrant is not found to be yellow, click on the appropriate checkbox so that we can get a crew out to repaint it. The hydrant shown was found on Ursula Place. Nobody seems to know who painted it. Many of our hydrants haven't been repainted in years. If you come across a hydrant that is in rough condition and needs to be repainted, click the checkbox for Needs to be Painted. Some hydrants you may see have a blue bonnet. Blue bonnet hydrants are designated service hydrants. This means that Public Works and some other companies with special permission from Aquarion are allowed to hook up to them and use the water from them. No other hydrants should be used by Public Works or private companies. If a hydrant has a blue bonnet, click on the appropriate checkbox. You may come across some hydrants that have blue rings around the steamer connection. These blue rings look very similar to the rings we put on when a hydrant is placed out of service. But these rings denote that the hydrant is for fire department use only. These hydrants are still in service and available for use by the fire department. They are used by Aquarion to remind third parties that they are not allowed to use just any fire hydrant in the city. To place a check in the box for any one of the attributes on the hydrant inspection form, you simply need to click the checkbox or the attribute title with your mouse or finger. Now, compare the hydrant number in our database to the hydrant number written on the hydrant. If they don't match, enter the hydrant number in the conflicting hydrant number box in the hydrant inspection form. Pressure testing hydrants. Again, just a reminder, please don't flush any hydrants during this process. In addition to a hydrant wrench, you're going to need some other tools from your high-rise bag and engineer's compartment. This includes the high-rise pressure gauge, a high-rise bleeder elbow, a 2 1/2 inch double female, and a 2 1/2 inch cap. We are going to use these to create a pressure testing device. Let's start by capping the end of the high-rise elbow with a 2 1/2 inch double female and a 2 1/2 inch cap. Next, attach the high-rise pressure gauge to the newly constructed elbow and cap combination to form the device pictured. Now remove one of the 2 1/2 inch caps off the side discharge of the hydrant and attach your elbow gauge combination to that outlet. Open the bleeder valve all the way. Next, slowly turn the bonnet nut, allowing the water to slowly fill the stem and the attached elbow gauge combination. Once all the air has been ejected, water will begin spewing out of the bleeder valve. Now, close the bleeder valve and finish opening the hydrant all the way. Read and record the pressure on the gauge. Only enter the numeric number into the inspection report. Do not add any text, such as PSI. Now, follow these steps to drain the hydrant and remove the equipment. Close the hydrant completely. Then, open the bleeder valve on the high-rise elbow to release any pressure. Test for a vacuum being created through the bleeder valve by placing a finger or palm over the valve openings. If no vacuum is noted, remove the elbow gauge combination and place the hand over the 2 1/2 inch port. If you feel a vacuum being created, the hydrant is draining properly. This could take a minute or two. If you don't, the hydrant may be a plugged hydrant. Look inside to see if the water level is level with the port opening. If the hydrant doesn't drain at all by itself, click the checkbox for Failed to drain after pressure test. Now, pump the hydrant dry. Plugged hydrants were purposely installed years ago in areas where the water table is close to the surface. This prevents water from filling the hydrant when not in use. Plugged hydrants need to manually be pumped after each use. If you look inside a plugged hydrant, you will see that the water level is going to be equal to the lowest port of the hydrant. It's important to test for water in the stem if the hydrant appears to be draining properly. Not all hydrants completely drain, and those are the ones that we need to pump. Open the steamer cap and allow the hydrant to finish draining as much as possible by itself. This could take a minute or two. Once you no longer feel the vacuum being created, carefully lower the string and weight through the steamer connection and into the lower stem. Allow the weight to drop to the bottom. Carefully pull the line up. If it appears there is still water in the stem, record the hydrant as wet and pump the remaining water out of the hydrant. If the string is not wet or shows some residual dampness, record the hydrant as dry in the inspection report. If the stem of the hydrant still contains water after the third pumping, click the checkbox indicating that the hydrant failed to fully drain on the inspection form. If you have any questions or are having problems using the app, feel free to contact me at any time. My email and telephone number are listed on this page. I hope you found this presentation useful.